Welcome to another exercise in the workbook statistics. This time I'm going to talk about an exercise on the normal distribution. So let's have a look at the exercise. A German TV channel shows the series Lindenstraße since 1985. On average, an episode takes 27.7 minutes, while the length can be considered as normally distributed with a standard deviation of 0.61 minutes. This already tells us we're going to use the normal distribution here. Well, with this cleared, our first task then is, what is the probability that an episode is longer than half an hour? Second, what is the probability that an episode will be between 26 and 28 minutes long? And finally, when cancelled in 2018, the series had 1,765 episodes. How much time is required to watch the full series? Well, let's start with the first part. So here, this was about the probability that one of the episodes lasts longer than 30 minutes. So we have the probability of x being larger or equal to 30. Whenever we want to calculate with the normal distribution something larger or equal to, we have to take the counter probability. So in this case, we have to replace this with 1 minus probability of x being smaller or equal to 30. Well, we have done what we're actually going to calculate here. We know from the exercise text the mean is 27.7 and a standard deviation 0.61. So we can use these two values to standardize the 30. Standardization means we're going to subtract the mean and we're going to divide by the standard deviation. So this gives us a value of 3.77. And well, this value stands inside this function of a big phi. Big phi means we're going to look this value up in our table of the standard normal distribution, because that's just short for use the corresponding result from the standard normal distribution. Well, if we look up this value, we get as a result 0.9999. So the end result is 0.01%. So less than 1/100th of a percent chance of one of the episodes lasting longer than 30 minutes, lasting longer than half an hour. Well, so much for the first part. In the second part, we were asked to determine the probability that an episode will last something between 26 and 28 minutes. Whenever we have an interval like this, what we're going to do is first calculate the probability that x is smaller or equal to the upper bound, that's here the 28, minus the probability that x is smaller or equal to the lower bound, that's here the 26. So we have these information. We also again know the mean and the standard deviation from the text. So we can standardize first the 28 and the 26. If we're doing this, here in both cases we're going to subtract the mean, divide by the standard deviation. For the first part we get 0.49 and for the second one minus 2.79. Problem here is the minus. Because in the table on the standard normal distribution, usually we do not have negative values. So what can we do here? Well, we can replace the whole expression here, the whole phi of minus 2.70 with 1 minus phi of and then the positive value. If we do it, we have here for the 0.49, which we can actually look up, 0.6879 minus, and then we have 1 minus phi so and so. Well, this translates into minus 1 and minus minus give plus, so we have plus phi of 2.79. This value we're also looking up. Here we get 0.9974 and we're going to calculate the result of all of this, giving us 68.53%. Well, like 68.53 5 roughly % chance of an episode lasting something between 26 and 28 minutes. And well, that was already the second part. So this leaves us only with the third and final part. And here we were asked about how long does it take on average to look through all of the episodes, so watch the whole series. Well, that's actually a pretty straightforward task, because the only thing we have to do here is just multiply the number of episodes with the average, with the mean, for each episode's duration. Well, if we do this, we get as a result 48,890.5 minutes. Well, we could then translate this into hours or days, but that's more or less the result of how long it will take to watch the whole series. Well, this then already concludes this whole exercise, which I hope you enjoyed. I say goodbye and see you next time.